Artificial intelligence is not just a software revolution. It is an infrastructure revolution. Behind every AI breakthrough, every chatbot, every generative model, every automation system, there is a vast physical backbone powering it. That backbone is expensive, and it is expanding at an extraordinary pace. Over the next decade, trillions of dollars are expected to flow into AI infrastructure. Not into apps, not into consumer platforms, into chips, data centers, power grids, fiber networks, and advanced cooling systems. Why is this happening? Because artificial intelligence is computationally intensive at a scale we have never seen before. Training modern AI systems requires enormous processing power. That power comes primarily from advanced semiconductors, especially GPUs and custom AI accelerators. These are not ordinary chips. The most advanced AI chips can cost tens of thousands of dollars each. And training large-scale models requires thousands, sometimes tens of thousands, operating simultaneously. One advanced AI data center can cost billions of dollars to build, and companies are not building one, they are building many, across North America, Europe, and Asia. Massive data centers are under construction. Some span millions of square feet. Some are located near renewable energy sources. Others are built near major fiber hubs to reduce latency. This is not incremental growth. This is an arms race in computational capacity, but chips are only one part of the equation. AI systems also consume extraordinary amounts of electricity. Training a single large-scale model can use as much power as thousands of households over extended periods. Running these models at scale multiplies that demand further. As a result, energy infrastructure is becoming deeply tied to AI expansion. Technology companies are signing long-term renewable energy contracts. New nuclear discussions are resurfacing. Grid expansion projects are accelerating. Electricity is no longer just a utility cost. It is a strategic resource. Then there is the physical challenge of heat. AI servers generate enormous thermal output. Advanced cooling systems, including liquid cooling, are becoming standard. This increases both construction complexity and operational cost. Every layer of the stack is scaling simultaneously. Semiconductor manufacturing, cloud infrastructure, energy generation, cooling systems, high-speed networking. This level of synchronized expansion is rare in technology cycles. It resembles industrial build-outs more than software launches. Why are companies willing to commit so much capital? Because control over compute equals control over capability. The more computational resources a company controls, the more sophisticated the models it can train. The more sophisticated the models, the more valuable the products built on top of them. This creates a powerful economic incentive. Early infrastructure investment can translate into long-term competitive advantage. And competitive advantage in AI can compound rapidly. The firms that secure the largest computational base may dominate entire industries. This is why capital expenditures among major technology firms have surged. In some cases, infrastructure spending now exceeds traditional research and development budgets. The focus has shifted from writing code to building capacity. And this trend is not limited to private corporations. Governments are also entering the infrastructure race. National AI strategies increasingly include domestic semiconductor incentives, subsidies for advanced manufacturing, energy security planning tied to data center expansion, strategic partnerships with cloud providers. AI infrastructure is becoming geopolitical infrastructure. The ability to train advanced AI systems domestically reduces dependency on foreign supply chains. Artificial intelligence is no longer just a commercial tool. It is becoming part of national industrial strategy, but AI infrastructure raises barriers to entry. Unlike traditional software startups, cutting-edge AI development requires enormous upfront investment that concentrates power and favors large technology firms and well-funded nations. This dynamic resembles past industrial revolutions. During the railroad era, capital intensity determined leaders. During the oil boom, infrastructure defined influence. Now computational infrastructure is becoming the defining asset. We are witnessing a new industrial cycle, centered on silicon and electricity instead of steel and oil. Trillions of dollars are not flowing into AI because of hype alone. They are flowing because foundational technology shifts demand foundational investment. AI is not lightweight. It is physical, it is electrical, it is structural. It is built on concrete, steel, silicon, fiber optics, and megawatts of power. The companies and nations that secure this infrastructure early may define the next phase of global productivity growth. That is why capital is moving aggressively. That is why energy markets are reacting. That is why semiconductor supply chains are under pressure. AI is no longer just a technology story. It is an economic transformation story. The AI boom is not only code, it is construction, it is energy expansion, it is industrial scaling. And the scale of investment tells us something important. This shift is not temporary. It is structural.